Okay, chapter 9, we're talking about chemical bonding. In this chapter, we're talking about the Lewis model, and then in the next two chapters, we're going to talk about different models for bonding. So back in 1989, the AIDS epidemic was going on, and researchers were trying to figure out what is this virus and what's going on and how can we stop it. And so they were able to figure out what the structure of HIV protease was. This is a protein that's synthesized by the virus and is necessary for it to replicate in the human body. So once they determined the structure of that, then they were able to find several molecules. They were actually designed several molecules to disable that protein. It has an active site, and if you can get something to bind the active site, you essentially disable it. Kind of like putting one of those boot things on a car. It can't go anywhere. And why we're talking about that now is that bonding theories were very important in simulating what sorts of molecules would be useful and possibly work to bind that protein. These protease inhibitors, as they're called because they inhibit the protease, they don't cure HIV, but they stop it in its tracks. So as long as the patient takes the drug, the virus can't replicate and take over, and so they can be healthy. It can actually reduce those levels to undetectable levels. I do not know what. Do you see my pointer? I don't know what it's doing. It has a mind of its own today. So bonding models or bonding theories, remember a law says what happens, and a theory or a model explains why. So bonding theories explain how and why atoms bond together to form molecules. Why are some molecules stable and some aren't? Why are some elements reactive and others aren't? And they also help us to predict shapes, and that's what they use with the protease inhibitor, is you need to know the shape of the molecule and how it interacts with something else. The three models we're going to talk about are different in some important ways, but they're all useful in slightly different ways to look at different aspects of bonding. And there's a trade-off, of course, between predictive power and complexity. The more predictive power you have, the better it explains things, the more complex it is and the harder it is to understand. So we're going to start off with the simplest one, the Lewis model. In the Lewis model, we represent valence electrons as dots. And we draw what are called Lewis electron dot structures, or sometimes I'll just call them Lewis structures, to show a molecule, to illustrate what a molecule is like. This is a very simple model. It's easy to use. It gives us quick predictions. Doesn't work for everything, but it works for a lot of things, so it's still very useful. It can help us predict the shape of molecules and help us predict if that molecule is going to be stable or not.